Let's integrate x squared times sine 5x. We're going to use integration by parts to evaluate this integral. We're going to need two formulas of integration that you should have learned in Calculus 1. If you didn't, then it's not very difficult. Just remember these. You can easily derive them. First, the integral of sine of ax is equal to minus 1 divided by a cosine of ax plus c. And then the second one is the integral of cosine of ax is equal to 1 over a times sine of ax plus c. And this is true as long as a is not equal to 0. So if a is any constant, not 0, these formulas will work. We're going to use integration by parts. Integration by parts is the following. It's the integral of u dv equal to u times v minus the integral of v du. So the hard integral is what we're going to call the integral of u dv. One part of it is going to be u, the other is dv. We then find du and v, express the hard integral in terms of the right-hand side of this formula. Hopefully the integral on the right will be easier than the integral on the left. When we're starting with a polynomial and a trigonometric function, such as this, we're going to let dv always be the trigonometric function. This is the rule of thumb that you should use. Let u be the polynomial, in this case it's just x squared, and then dv be sine of 5x dx. We want to make du easier than u, so here du will be a lower degree polynomial. It's 2x instead of x squared. And v, using one of the formulas above, here a equals to 5, so v is minus 1/5 times cosine of 5x. Now let's use integration by parts. The original integral that we started with, x squared times sine of 5x. This integral is the integral of u dv. This is equal to u times v, so minus 1/5 x squared cosine of 5x. There's nothing here to finish. This is already done. Minus the integral of v du. Now notice that v has a minus in it. Minus a minus will turn it into a plus. 2 times 1/5 would be 2 over 5 times the integral of x cosine of 5x dx. Now the integral on the right, this is just our uv, and all of this is the integral of v du. And the integral on the right, it's still not finished. We can't just use the formula, but it's easier than the integral on the left in the sense that the polynomial is x to the first, and on the left it's x squared. Now I'm going to leave 2/5 alone for now and just integrate the integral that I'm circling, then come back for the 2/5. So we want to integrate x cosine of 5x. You let u be the polynomial part, and dv once again a trigonometric part, cosine of 5x dx. Du is just 1 dx, and v, using the formula above, is 1/5 times the sine of 5x. So this integral equals to u times v, the new u and the new v, so it's 1/5 x times sine 5x minus the integral of v du, which is 1/5 times the integral of sine of 5x. Now the integral on the right is just an application of the formula, so this is 1/5 x sine of 5x, and the integral of sine of 5x is minus 1/5 cosine, so this is plus 1 over 25 cosine of 5x. Now we're ready to finish the original problem. The original problem, recall, was the integral of x squared times sine of 5x. In the first time we used integration by parts, we got minus 1/5 x squared cosine of 5x plus 2/5 times the integral of x cosine of 5x. Well, we just found that. Here it is right here, this part. So plus 2/5 times 1 over 5x sine 5x plus 1 over 25 cosine of 5x. We can now add a c because we are done with integration. There's no more integration left. We just have to simplify it. And so here's the final answer. The integral of x squared times sine of 5x equals to minus 1 over 5 x squared cosine of 5x. 2 over 5 times 1 over 5 is 2 over 25 x sine 5x plus 2 over 5 times 1 over 25 is 2 divided by 125 cosine 5x and plus c.